So you've seen why we need a message queue, and AMQP stands for Advanced Message Queuing Protocol, and it's a protocol that enables conforming clients applications to communicate with conforming messaging middleware brokers. Now, what are these brokers? Well, a broker receives messages from publishers, i.e. these are applications that publish messages, and they're also known as producers, and it routes them to consumers, i.e. other applications. So the broker receives messages from publishers and it routes them to consumers. Now, since this is a network protocol, the publishers, consumers, and the broker can all reside on different machines. So you can see how you can decouple your applications. So in here, you've seen that we have these microservices, they talk to each other. And currently, if customer sends a notification to the notification microservice and notification is down, or notification is having trouble handling requests, then you can see that this can be a bottleneck for our application. And instead, what we do is we use RabbitMQ in this case. Now, I'm going to touch on RabbitMQ, but later you'll also see Kafka. And I don't want to go too much in detail about the difference between these two, but for now, let's just focus on RabbitMQ. Now, the broker is everything that resides within this rectangle in here. So the way it works is if fraud or customer, they want to send notifications to the notification microservice, they send a message, and the message is pretty much the payload, right? So the JSON payload in our case. Now, this message here gets sent to the exchange, and the exchange job is to route the messages to the according consumer. So in this case right here, you can see that this exchange forwards these messages coming from fraud as well as notification, and then notification consumes the messages from this queue right here. So fraud, customer are producers. The messages go through the exchange routes to the queue. Inside here, this is the broker, and then outside we have the consumer, which can be any microservice that is configured to pull messages from this queue. And with this architecture, we gain a ton. So one is loose coupling. So fraud, customer, notification, as well as the broker, they can live on separate machines. And since we are following the microservice architecture, this is actually loose coupling all of these services together. The other thing is performance. So we gain performance. Now, if notification is down, let's say that notification is down, right? So let's say that we don't have a consumer right here. Now, the cool thing is that fraud and customer, they can still send notifications. And at this point right here, the exchange right here receives and then puts it inside of the queue. Then once notification is back up, it pretty much just reads the messages that were hanging in the queue. And the benefit is that our clients don't even experience that notification was down. Also, we can start sending messages asynchronously. So if, let's say, Twilio is taking 20 seconds or more, it doesn't really matter, because from our point of view, if any producer is able to publish messages to the exchange, then we are good. We can also scale in a way where if you need to run this as a cluster, 2 or more machines, you can absolutely do it. And you should run multi-AZ whenever possible. Also, the benefit of using RabbitMQ is that it's language agnostic. So let's say that fraud right here, it's written in Java, and notification is written in Golang, for example. So it doesn't really matter, right? Because all notification needs to do is to be able to pull messages and then transform the payload into whatever struct, for example, if you're using Golang, or if you want to use Python, then it basically takes the messages and transforms it in a way that it wants. Now, messages also, they don't get removed from the queue unless the consumer acknowledges that it has received the message, which is a good feature, right? So if notification has issues reading from the queue and the broker doesn't receive an acknowledgement, then the message is still intact. RabbitMQ also offers as a management UI, which you'll see in a second, and the community has built lots of plugins, and you can run RabbitMQ on the cloud, which is a good thing, right? And we'll see how we're going to run RabbitMQ through Docker. And as you know, if you Dockerize your applications, then it's really easy for you to deploy on whatever cloud provider you want, whether it's AWS, Azure, Google Cloud, Linode, and others. So this is pretty much how everything works. Next, I want to dive deeper into how producers are able to produce messages, as well as the different types of exchanges.